absolutely delighted to have you here and host you for your first delivery of pattern extraction in Power Query in M, and absolutely thrilled to bits that it's your it's the day that you've received your book, so that you've authored. So
it's actually here. Yeah,
it's here. You've got it. So what I'm going to do is I'm going to hand over to you and let you continue with the recording. So I'll stop sharing.
Awesome. So then it's my turn to share my screen. There we go. Let me know if you can see that.
Yes, perfect.
Awesome. So I'm very thrilled to be here today. Like Sue already mentioned, it will be my first time presenting this session, which is an introduction to pattern extraction in M. So today it's all about going on a mission to extract patterns from unstructured data. By that, I mean anything meaningful bits and pieces of information that are embedded within a string. Judging by the amount of form question that a topic like this generates, it's a task often easier said than done. So whether it's pulling out an item code, email address, or something as trivial as a date, I bet many of you have faced or will face a challenge like this. Keep in mind that it's also a very broad topic, so you'll often encounter that no two scenarios are exactly alike. Therefore, I'm hoping you will focus on some of the techniques that I'm showing and not so much on the sample data that I am using. Let me briefly introduce myself. So my name is Melissa. I'm part of the Ademos team in the Netherlands. That's a company that manufactures diamond tools for drilling, sawing, and grinding. And my role there is focused around digitization, automation, and of course, data analysis. I am an enterprise DNA expert and Microsoft Community Superuser, in both cases for my contributions to the forum. And on March 29th, the Definite Guide to Power Query M was released by Pact, of which I am a co-author. Furthermore, I share tips, tricks, and what I've learned on LinkedIn using the hashtag that you see at the bottom of the screen. You're welcome to follow that or connect with me in that space. All right. So what do I have in store for you today? Well, during this session, I'm going to highlight two very important concepts in the M language first, before we get to the main course of this session, which is pattern extraction. Without doubt, a must-have skill, often associated with regular expressions available in other program languages, which are not native to M. So there's a feature within the user interface called column from examples. Now, I won't actually demonstrate that because it's quite intuitive in its use, but it may be helpful in some cases when you need to extract a pattern. If you've never used that, please give that a go. It can definitely work at times. But keep in mind that it's not perfect and it may not always work. So there will be instances where this feature fails and it generates some code that just doesn't work. And the same actually goes for the sample that I've depicted here on the screen. I've got strings, and these strings all contain a number of hashtags. Now, using column from examples, I was not able to extract them successfully. We will take a look at what happened and why that happened in a moment when we'll examine the code. So when it comes to extracting patterns, there are a couple of things that can help you on your way. First, give column from examples a go. It may help, or it may not. And when it doesn't, when it fails, you have to devise some strategy to extract that piece of code, that meaningless piece of information on your own. So when you think about that, there are two major things to gaining success. First is that you have to understand the data and of course the pattern to extract. And second, there are some functions that you need to master. When it comes to extracting patterns, you need to understand two function groups. The first group that operates on text type values, and the second group that operates on list type values. So in any case where you have to break a string apart into smaller pieces, then you'll have to resort to list operations. With that said, let's head over to the Power Query editor. So when working inside the Power Query editor, it's a best practice to have both the formula bar and the query settings pane visible at all times. When that's not the case, you can head over to the View tab and toggle them on right here. So enable or disable the formula bar, and the same goes for the query settings. So in order to do more with Power Query, you need to have an understanding of two fundamental concepts, and these are the let expression and the each keyword. So I'll introduce the let expression first. That is a construct that is automatically generated by the M engine as you generate a query. So even if you create a blank query, it will already contain a let expression. So let me demonstrate. I'll right-click inside the query pane and select New Query, Blank Query, and I'll open up the advanced editor. Let me zoom in. So here we see a let expression. It starts with a let clause that is on line 1, and the counterpart of a let clause is the in, and you find that on line 3. So whatever you return after the in clause, that will determine the result of your let expression. In this case, we're returning source, which is a variable name, and that has a value assigned to it, an empty text string. But we can just as easily change that into something else. So we can create a simple expression, let's say 1 plus 2, and press done. Now the result of my query returns 3. Now, of course, it's very unlikely that you'll do something like this, but what I want you to take away from this is that this is still perfectly valid M code. All right, let me take a zip. So let's take a look at a query that I've prepared for you. And I'll open up the advanced editor so we can take a look at the code. I'll zoom in. So again, we are looking at a let expression, right? We have the let clause on line 1 and the accompanying in clause on line 13. And in between, there's a comma delimited list of variables with values assigned to them. Now, a variable allows you to store a value that can be reused and passed along to another expression. So this allows you to break more complex logic down into smaller components or steps that make a query easier to debug, modify, and maintain. So if I select emails, I'll see the value that returns. That variable stores a list with 4 items. Equally, I can extract the extract domain step, and that also returns a list with 4 items. And the final step, which is the result of this query, returns a list that contains 3 items. So let's return to the advanced editor and see the code again. So emails, this first variable, we saw that it returned a list. But examining the code, we can also see that it generates that list. We have the list initializer here, which is a set of those curly brackets. And in between, there are text strings, which are separated by commas. There are 4 text strings within this list, Therefore, this list, of course, returns a list with 4 items in it. Then, in extract domain, we see that the email list that we generated has been reused. We are passing that variable onto another expression. That email list is passed to list transform. And this is the first time where we see an each expression. Now, when you encounter the each keyword, that implicitly creates an inline function that takes a single argument that's represented by the underscore. Now, this provides access to either the current row in the table or the current item in a list. Effectively, it means that whatever expression follows the each keyword will be applied to all of the rows or all of the items within that list. In this case, we are seeing the function text after the limiter. And here the underscore represents each of the values that are stored within the email list. That allows us to perform this transformation on all of the list items. Finally, that is passed on to the unique domains variable list. And that will remove all of the duplicate items from that list. All right. So what have we learned so far? Well, we've learned that a let expression allows us to construct a more complex expression within the M language. Variables are there to store values, and that can be passed on to another expression within that let. The outcome of a let expression is produced by whatever follows the in clause. And we've seen that each keyword is syntax sugar for a unary function, and that whatever follows it will be applied to each row in the table or each item within a list. Are there any questions so far, Sue?
No questions as yet. I think everybody's just literally taking it in one step at a time, understanding the process. If they're like me, I'm looking and thinking, right, okay, so Bogdan's got a question. Yeah, Claire's put concentrate in. Bogdan, do you want to pop it in the chat? Or to speak?
No, my apologies. My apologies. Was I misclicked? Sorry.
No worries, Bogdan. Nice to speak to you anyway. Darren's asked, so Claire's put concentrating, and Darren said, can something other than the underscore be used?
Definitely, but not in combination with the each expression. So with the each expression, you only get one variable, and that is the underscore. Okay. When you create your own functions, you can assign whatever variable you want and you like, and then you can reuse that.
Okay, brilliant.
Does that make sense?
Yep, it makes perfect sense, and I'm loving where this is going. So I think we're all just sitting literally in intense concentration, taking it all in.
Perfect. Well, as mentioned, the process of pattern matching actually begins by understanding your data and the pattern that you want to extract. And let me select my next query. So here we see the data that I also had on my slide earlier, right? I have these text strings that all contain hashtags. And the goal, of course, is to extract all of the hashtags that are embedded within these sentences. Now, this is a perfect example of a prefixed pattern, right? Each pattern starts with something that will allow you to ID it. Now, remember, I promised that we would take a look at the code that Column from Examples had generated when I used that feature on this sample data. So I'll open the advanced editor here, and let me zoom in as well. Let's make that a bit bigger. There we go. Awesome. So to make it easier to read and write this code and to understand it, of course, I formatted it, and I did that by hand. But there's also an awesome website out there called powerqueryformatter.com, which allows you to format your code, which is truly an honest tool and an awesome tool. And I hope that you will take a look at that website and give it a go. I'm telling this because basically when you use the user interface, all of the code that's generated by the M engine will be written in a single line. And that means that it's very hard to read and to make sense of. You'll often find yourself scrolling from left to right. If you don't like that, there's also a display option here that you can use, and that's enabling word wrap. That means that it will, depending on the width of the advanced editor, it will move your code to a new line. And that will limit the amount of scrolling that you have to do to read your M code. So while I was talking, did any of you already spot why this code that we're looking on is actually flawed? Please drop your ideas in the chat. And just give us your best guess. I mean, we're all here to learn. Let me see if I can find the chat.
It's all
Right.
hard-coded
Exactly.
text, so many else ifs.
I've got so many brilliant people here. It's awesome. Yes.
Yeah, we don't like the red. I would have gone for hard-coded.
Exactly. That's exactly the problem. So everything this text is doing, it's picking up.
And the else if.
It's picking up the text right from the actual current line in the table, and it's hard-coded the full string. And it says, look, if I encounter that full string again, then I know you want these hashtags. And I've got, let's see, 5 lines of data, and I also got 1, 2, 3, 4, 5 lines of hard-coded values here. There's a 6th, of course, meaning that if any new data comes in, which doesn't exactly match a string that is already present, I'll just return a null value. So this solution is not dynamic at all. And basically that's the extent of it. Column from examples can produce dynamic code, but sometimes it fails. And you need to be aware of this limitation and examine the code that a feature like that generates. That's totally up to you, the user, right? So admittedly, this is a small sample, and the thing which I think tripped up the M engine is that those hashtags are not in the same place. But let's try to figure out a solution ourselves. So here's my query, exactly the same data with those hashtags. And the first thing I'm going to do is I'm going to create a column to store those values that I want to extract. I always do that via that mini table icon in the top left corner. So I'll click that and I'll add a new column. Now I'm not at all bothered with the column name at this stage. This is just for exploration, right? So the first thing that I'm going to do is enable myself to examine every word within that sentence. And to do that, I need to split up these strings. So there's a function called text.split, and we'll use that. So text split. I usually type a few characters that will allow IntelliSense to come up with some suggestions, and then I'll use my arrow keys, hit tab to select one that I like so. That will save a lot of typing. So text.split, I've got that selected here in the available columns. Of course, I only have one column, but I can select my field to enter that as a parameter to the function, hit comma, and now I can enter a separator as well. Now I want to split my text on a space character. So as a text string, I'll hit that space, close my function, and press OK. So a splitting operation that will expect a return value of more than a single item. Therefore, it generates a list, which makes sense if you think about it. If it helps in visualizing what's going on, you can think of it as a one-dimensional array even. So just click on the white space beside the structured value. That will open up that secondary preview down below, and that will allow you to see the contents of that list. Perfect. So now we've got a list of items. That means that we have to also call upon a list operation to do something with the contents of these lists. And we want to select items that start with that hash or pound sign. So inside the formula bar, I'm going to add a function. So I'm going to nest functions inside each other. And I'll use list select. Open that up. So the first argument, that's a list, and that's provided by the text.split function. That's the thing that we're also seeing on the screen right here. Then it wants a selection function. So we need to create a logical expression that will evaluate to either true or false. If it evaluates to true, that item will be kept within the list. And when it evaluates to false, that item will be omitted from the list. Now again, we want to do an operation on each value within the list. So I'm going to start by calling the each keyword. And the function that I'm going to use is text starts with. Now to get the current value from that list of items that we're working through, I need to enter the underscore here as the variable, comma, and as a substring, I can enter the thing that I'm looking for. In this case, that hash or pound sign. So as a text, I'll enter that. Let's see if I've got all of the closing parentheses. Perfect. And hit that check mark. All right. So let's take another look inside of these lists. Awesome. That's looking good. So one more thing to do, and that is getting all of these list items back together into a single string. For that, we can use a function called text.combine. Again, I will nest that, so I'll wrap that around the syntax that we're seeing inside the formula bar. So text combine. Hit a comma, and as a separator, I can provide it a comma and a space. Press that check mark. Awesome. So we've now extracted all of the hashtags that were embedded in those strings. I can also ascribe this column a type. Right now, you see ABC123, but it is a text type, so I can say type text. This will ascribe a type to that column. It won't actually convert a type, but it will ascribe a type to that column. So now it says ABC, meaning it should be a text value. So what did we learn? Well, we've basically learned the basic recipe, if you will, to extracting patterns. You start by splitting up a string into smaller components. Then you create some conditional logic that identifies the pattern, and in this case, all of the hashtags. And finally, you combine what remains and return that as a single string. All right.
Yeah,
Any
we've got
questions on this?
a few questions and discussion. So Grenine first asked, why didn't you use the hashtag in text.split for the first when you had the text column? And sort of people have come back and said it's easier to keep the words untouched because you're splitting the column. And then there was a question saying, is there a performance advantage in storing variables via let stroke in an effort to realize fewer applied steps?
Not sure on the last one. So on the first one, definitely. If you split on the hashtag, that may help in some cases, but it won't get you the entire hashtag. If you split on the hash or pound sign, it won't allow you to extract the hashtags because you lose that pound sign or hash when you do that in splitting operation. Plus, additionally, any remaining text will be there as well. So I don't think that's a preferred. I would definitely not prefer that as an approach. So that would be my thinking and my way of going about it. And what was the second question again you had, Sue?
So the other one was about performance. So if you're, writing a long function with the let and then the in and having the variables within the function, is it more performant to have it as one step within the function as opposed to sort of where you've nested them in one step? I think I'm getting your question right, Sean. Is it easier? Is there any performance to do that within one step rather than building many different steps?
There can be, but it's to the best of my knowledge, it's not guaranteed.
Yeah.
So especially, and we'll definitely touch on this a little bit more.
Yeah,
at a
I think it is.
later stage.
Yeah, it's like Adam said, it's, with Power Query, it depends so much upon your data and what you're pulling in and not pulling out. And then there was a discussion about if there was no hashtag, whether it would error out or provide a null.
It won't error out at all. It won't provide a null either. It will provide an empty text string. So that would be the result with when there's no hashtag to be extracted.
Yep, cool, brilliant. So yes, so we're all transfixed and chatting.
Awesome.
And watching and learning. So
keep that going.
Keep that going.
Definitely keep that going.
Yeah, ready for the next.
Awesome. So for the next challenge, if you will, we're looking at structured patterns. In this case, we're looking for a pattern that's structured as a date. And our task is to extract all of those pieces of data that look like a date. So looking at the data, I mean, the process again starts like it always does, by examining your data. So what stands out to me are a couple of things. First, that not all of the dates are denoted in the same way. We have a hyphen here, then a dot there, some forward slashes there. So they're not all written in the same way. However, the way they are structured, so the length of each date, that seems to be consistent. So we have 2 positions for the days, 2 positions for the months, and 4 positions for the year. And one final observation is that sometimes we see a punctuation mark that follows exactly at the end of a date. So that's something that I picked up when I looked at this data. So let's see where that knowledge takes us. Again, my opening move will be to split this string apart. So I'll add a comma. Sorry, I'll add a column. There we go. Use text split. Enter that text value. And again, we will split it on the space character. Press OK. What did I do? Text select, text split. There we go. Awesome. So here we see that sometimes we have that date with a punctuation mark at the end, right? Now, ideally, that's not what you want because that will make a date harder to identify. So to get rid of them, I want to transform the contents within this list. I'll open up the advanced editor and let's zoom in a bit. So here's my syntax, and currently I did not provide this a name. I'm going to create several steps, so I could create a record expression, but in this instance, I will stick with a let expression because that's the thing that we discussed. So that starts with the let clause, then should be something of an in clause, but let's first assign a name. Not too bothered with the name, so I'm just going to say, look, this first operation that I did, I'm just going to call that A to be brief. And here I can return something which I will do in a while. So I'll add a comma. That means that I can create a new variable within this nested let expression. You might have guessed already, that will be B. And here I can transform my list. So list transform, that's the function that I'm looking for. Now that will take the list that was generated by text.split, which is stored inside the variable A. So I'm going to pass the variable A here because that represents a list, something like we see on the screen right here. And now we can provide a transformation to transform each of the values stored within that list. Now, I want to trim any of the punctuation marks that are at the end of each of those text, right? So for each item in my list, I want to trim the end. So text, trim, and there it is. I can access items from the list by using the underscore and trim as any. Now, usually you provide the text trim function a single character, but you can also provide a list with multiple single characters. So using those curly brackets that we saw earlier, we'll generate a list, and my first single character will be a period, and my second single character here will be a comma. Let's see, I have a closing parentheses there and there. Perfect. So let's return the value for B. Let's press done and take another look inside. So awesome. That got rid of those punctuation marks. Now what I'm thinking right now is to see if I can convert all of those values that look like a date into a date. Keep in mind that the selection function that we saw earlier, that needs to evaluate to true or false. Now, a date, of course, is not a logical value. Therefore, I have to use another function. For example, value is, to see if that conversion worked, and that returned a data type. Let's see what that looks like. I'll open the advanced editor again. We'll create another variable within this let expression. So place a comma at the end. Let's call that C. And here we will select items from that list. So list select. We'll pass in our transformed list, so the list B. And now we can generate that conditional logic. So for each item there, we'll use value is. Open that up. The value will be the date from the value that I'm passing in. So that's a conversion function, date from. Here I'll pass the underscore to get each of the list items. And when that conversion is successful, the data type of that value will be of a date data type. So date type. Let's see, I have everything. Perfect. Let's press done. Now, no surprise, that returned an error. And errors are nothing to be scared of. Errors are a signal that you need to modify your code just a little to get there where you want to go. The thing is that you need to find out what is causing the problem, so why your code up to now failed. So what I'll do is I'll click on that list item here. That will drill us down into that value. And now I can click beside the error in the white space. And it tells me data format error, we couldn't parse the input provided as a date value. Now, I can definitely imagine that this does not speak to you. So let's remove that and let me try to explain what the problem is that we've encountered. I'll open up the advanced editor once more and I'll zoom in. The problem here is that date from will convert a value. And I think everyone here has encountered errors when they transformed column data types. And there was some value there that couldn't convert to the value that you've selected, and it caused an error to appear. The same thing is happening here. Not all of the items in my list will be able to convert to a date data type. And those are causing an error. Now, to deal with that error, the M language is equipped with some error handling capabilities. So in this case, we can use the try and otherwise clause to help us out and resolve this. So a try clause will evaluate the expression, or at least it will try to evaluate the expression. And when it fails, it will return a record. Now, otherwise will then will allow you to specify a default value for when an error is raised. So try means you're testing the value. If it returns an error, then the otherwise clause will take effect. So to stop an error right in its track, you want to place that try and otherwise construct right there where you expect the error to be raised, which is here inside the value is expression, right? Because data from, that's the thing that is causing the problems. So I'll add the try clause here and add the otherwise. That's no English. Here. Now, as a default value, I can pass basically any value that I can think of, except maybe for the date. Because when I pass a date, then this expression will return to true, of course, and everything in my list will be retained. So any other value will be okay, because then that value won't be equal to a date, and value is will return a false. So if I return false here, just to help me out, false is a logical value, which is not of a date data type, and that will cause the expression of a value is to return a false as well. So let's see if this did the trick. I'll press done and take another look inside of my lists. Awesome. So it was even able to convert these values that were denoted in a different way. Perfect, we seem to have everything. That means we can combine the result of this expression again using the text.combine function. And I can do so right here. So let me look up C. So just use text combine to take that list of values that have remained and combine them into a single string. Again, adding a comma and a space, closing that off, and hitting that check mark. Perfect. So what did we learn here? Well, we've learned that punctuation marks can be removed quite easily when using the text.trim function within list.transform. We've also seen that conversion functions can raise errors when they encounter a non-compatible data type. And of course, that try and otherwise can help you deal with errors by specifying a default value. So any questions so far, Sue?
We're all chatting about it in the chat. So there is questions. Basically, it's brilliant because everybody's supporting each other. So when anyone asks a question, there are some real Power Query whizzes in here. So everyone's supporting and chatting with each other and watching what you're doing. And I think my favourite was Brian Julius, who said that you've been spending too much time in Power Query when the error messages start making sense to you. But Aurora had a question about how to handle a valid date, and then other people have put in some ways in which you can use locale, and so it's brilliant. And some baby novices too, Claire says. She's not that baby a novice, but so I think, Melissa, we're chatting amongst ourselves, supporting each other, learning, and we want to see the next one, is what I would say.
Okay.
So next, please.
Definitely coming up. Just one small remark. If you have a function, or if you have a date that doesn't seem to conform well to a date, you can use date.fromText instead, which allows you to specify options. So among them, a format and also locale or a culture in that sense. So that's just a small tip that I wanted to provide.
Brilliant. Thank you.
On to the next one.
Next, please.
Yes, coming up. Don't want to miss yoga. There we go.
Oh, no, not that. I'm just transfixed. I don't want to miss yoga, but the way you explain things, Melissa, it just really helps things become clear. So it's a real joy listening to you. So thank you.
Well, thank you so much for that. So final scenario is already here. And now we're looking to extract.
You need to share your screen again.
Awesome.
Missed the share screen. Just check. So can everyone else see it, or is it just me?
Let's see if that works.
Here we go. That's it.
Yeah. Awesome. Sorry about that.
No problem.
Okay, so for the final scenario, that is dealing with extracting a fixed pattern. Now, that can be anything, of course. In our example, it is 4 capital letters followed by 7 digits. So that's the thing that we need to extract from all of these sentences. Now, of course, we're only interested in things that match this pattern precisely. And when this is something that you find is common to your data, then you'll probably need to create logic that you can reuse multiple times. That means creating a custom function, and that's what we'll be doing right now. So when creating a custom function, you can define each parameter and its type. Now, that means that any argument value that you supply to your function later on will need to be compatible to the corresponding parameter type. That provides some sort of protection for your function, as you will find out, I guess, when you start exploring this on your own. So let's go. I'll open the advanced editor window and zoom in. Now, here's a tip that I'll share with you. When I create a custom function or any other manual variable, I create that above my source step. And the reason for that is that when you interact with your query later on through the user interface, you're very unlikely to disrupt any of the code that you've created by hand. So it's just a trick that I want to share. I'll create it here. And the name that I'm going to specify, or the variable that I will create, that will also be the name of the function when I need to call that logic later on. In this case, I will call that lookup function. It's a variable, so I'm going to assign a value. In this case, that will be a function value. Now, functions are created with a set of parentheses followed by the goes to sign. That looks like this. So that's basically how you create a function. And in between those parentheses, you can create parameters. Now, in my mind, I quickly created 3 parameters that I needed to create. I need to supply my function with a text value that I need to look in for the presence of our pattern. I want to specify a number for the number of capitals that should be that first part of our string. And equally, I want a number to specify the number of digits that should be at the end of my string. So let's do that. Let's call that lookin. That will be a text, so as text, comma. My second parameter, that will be a letter count. That will be a number. And the same for the digits, right? That will be a number count. And that should also be a number, as number. Now, after the closing parentheses, you can also specify the function return value, or at least its type. And as you've seen from all of the previous examples, we're creating strings. Right, so here we can say as text. So this function eventually will return a text string. So with this in place, we can focus on creating the function body. Now the function body, that's the piece of code that will be evaluated when a function is invoked. So I will generate that step by step, making small pieces of code that I can reuse, like the let expression that we saw earlier. And exactly what I'll be doing now, I'll be creating a let expression to make those building blocks possible, right? That starts with the let. And of course, we have the in clause as well, and in between should be our variables. Right. To quickly discard any piece of text that won't possibly match our pattern, I can test for the string length, right? So I'm going to create a variable first that will have the character count of the pattern length that I'm looking for. So I'll call that pattern length. And simply that is the letter count plus, of course, the number count. That should be the full string count as well. So at this time, we need to match the composition of the pattern as well. Now, that requires some additional logic, and I will nest a function within this function that allows me to do that. I'll call that isPatternMatch. And that will be a function that takes a text value. Remember, we will be operating on a list of text values. I'm going to call that T. There's no reason for me to specify any of the argument types because this function is never going to be used by anyone directly. It's going to be used indirectly by me, and it will operate on the look-in text function that we will split later on. So it will take one argument there, and then we need to perform two tests. We need to see if the first bit of the string, if that is comprised out of 4 capital letters. Let's start with that. And take a zip. So to extract the first characters from a string, we can use the text start function. So text start will input our variable t, and the first part, that will be the letter count. So this will extract in this case, the first 4 characters from each of the strings that we'll be passing to this function. And now we have to see if those first 4 characters are capital letters, right? Now, a simple way to do that is by removing any valid characters and to test whether your string is empty or not. So in this case, I'll say text remove. I'll input the characters that I have, and for the characters to remove, that will be a list of all of the valid characters. So that starts with a capital A and runs all the way up to a capital letter Z. Now the result, if we only had valid characters, that means that the result of this expression will be an empty text string. Of course, that is not a logical value. So we need to compare that against an actual empty text string. So I'll say each empty text string, or sorry, equals empty text string. Right. Now there's one more clause that I need to create because I need to do the same test basically for those number of digits, right? So I'll say end, copy this bit, move to a new line. So instead of text.start, we'll now be extracting the final part of each of the text strings, so text end. And instead of the letter count, we now want the number count. Of course, valid characters for those digits, those will run from 0 all the way up to 9. Again, if there are only valid characters, text.remove will remove them all, and the result will be an empty text string. Therefore, that part of the statement will then evaluate to true. Now, if both of these statements evaluate to true, then the is pattern match will return true. If one of them does not, or both fail this test, then is pattern match will return a false. Awesome. So now we can take a look at quickly eliminating everything that does not need to undergo a pattern matching logic, right? So we can quickly discard probably most of the items within our list by just basically comparing them to the text length, comparing the text length with the pattern length. Let's do that first. So we'll add a comma here. We'll say items, and we'll select items from a list that we still have to create, because we have that looking text. That's the full string that we're passing to this function, and we have to break that up by a space, right? So text split, input our looking variable, and again, we're going to split that by a space character. That returns a list, and from that list, we can remove anything for which the length does not match the pattern length. So each text length, pass in the underscore to check each current item in the list as we're evaluating each of the items there, equals pattern length. So if this test fails, the item is removed from the list and disregarded. Anything that matches the pattern length, those items, that will be a very small subset of everything within the list. Those are the items that will undergo the is pattern match testing. So create one more variable. And let's call that matches. Again, we'll use the list.select. And now we'll use the items that are left from that first operation to pass in our is pattern match function. So for each item in that list, we want to invoke is pattern match. Pass in the underscore again to access all of the items within that list. And that will, of course, result in either some value to be found or none of the items to be found. Of course, if any items remain in that list, we want to combine them into a single text string. So text combine, pass in matches, and combine those with a comma and a space. Don't forget to place a comma at the end and press done. All right. Moment of truth. Do we have a function value? Yes, we do. Awesome. So now we can invoke this function on our data. So here is our source. Again, a custom function is just like any other function. So we'll add a custom column to our data set. We'll call that function by its name. So that's lookup function. We'll pass it our text string. Then the number of letters to expect, 4 letters. And the number of digits as well, 7. Let's close that off. Press OK. Awesome. And again, we can also ascribe this column a type. Type text. There we go. Hit that check mark. Awesome. So what did we learn? Well, we've learned that custom functions are an easy way to generate reusable code. When defining a function, you can specify parameter value types, and those need to match the corresponding argument value type that you pass your function. All of the examples, they all required a different technique, but the basic recipe to pattern extraction is quite consistent. You split up a string to take a look at each of the individual words that you find there, define some conditional logic, or a logical condition, I should say, to find the items that you need to retain, and then join them all back together again to form a string. So that's all I have for you guys today. Are there any questions so far?
That was just brilliant. So I don't know if you saw, but there were so many appreciation of claps and smiles and hearts, etc., from the reactions from everyone, with superbs and brilliant and extra. So again, lots of chit chat in the chat, including talking about data validation with dates. Brian's mentioned, yes, you could do use Python or R and use regex and within Power Query, and then return those results back to Power Query. And Tim has said, instead of having this function in this query, is it possible to have this as a separate function outside of the query and then reuse for other queries?
Yeah, just grab that bit of code. So the function, that's this bit. Just grab that, press done, create a new query. So again, new query, blank query. Open up the advanced editor, select everything you see there and paste that in, and press done. And here's our function. And you can give it some smart name. So fx lookup. I don't know, something like that.
Perfect. Brilliant.
So yeah, that equally works well. And you know, when you've invested in generating a function that you can reuse over and over again, you'll probably store it somewhere where you, your coworkers, and anyone that needs to take advantage of it has access to it. So yeah, it's also a perfect way to apply the same logic over and over again, right? To be really consistent in the manner in which you do things.
Definitely.
Yeah.
So a few people, you know, just lots and lots of praise, and people saying, this is recorded, so it will be uploaded to YouTube because people want to watch it back again. Are we able to have the PBIX, Melissa? Are you, because we have a GitHub site for the user group. So are you releasing that for people to play along with and rewatch?
Definitely, yeah.
Yeah, I was going to say, I think you normally do, don't you? And am I right in thinking you've got your own GitHub site as well, where you've got different bits of lovely patterns that you keep?
Not at this time, not yet. No, no.
There
I
you
do
go.
have. I'm an Enterprise DNA member, and they have a site where you can store codes, and that's where I usually publish code.
That's where I've seen it then.
Yeah, but it's not public to anyone, so I'm definitely thinking about finding another place for that.
Yeah, well, yeah. I know Brian has, haven't he? Are you still there, Brian? But I know Brian Julius does as well.
Yeah.
So there are some nice GitHub sites. But yeah, I will put Melissa's presentation into the GitHub site. But Melissa, the things in the chat, everyone is just fantastic. Thank you. And you have a real talent for explaining complicated, indented functions and how you can use Power Query in a really clear, beautiful manner. So I absolutely love hearing you give these explanations. So so it's absolutely brilliant. So yes, Brian, I'll be after you and put your GitHub, a link to your GitHub in there as well. So Melissa, that was
sorry, Steve, but for anyone who thought, you know, I like this, I'm getting the hang of this pattern extraction, that's a whole new world for me, and I want to learn more about it. I'm gonna wave this thing one more thing just because it's so heavy, just once more. I'm gonna put up my book because, you know, we've in chapter 14 there are about 25 pages devoted to this topic alone.
Listen, and there's that's still the page I've got it on, Melissa. That's the page I've got it open on. Definitely. Custom functions, page 365.
That's the custom function bit, but chapter 14 that talks about
patterns.
About patterns, or at least about how do you say that again? About resolving issues, troublesome patterns. That's the thing that I'm looking for. And there are like 25 pages devoted to this topic alone.
Oh, we've lost your screen again.
Yeah, I'm sorry about that.
Oh, no, don't worry. But yeah, it's a brilliant book. Absolutely brilliant.
And it's, I'm seeing Stephen. Thank you. Yes.
Yes,
and
thank
Salil, thank you as well.
Yeah.
So there are like a lot of pages devoted to this topic alone, and to be honest, there's still more to be said about a topic like this. So it's probably never ending. There are too many scenarios, and you can write a book on this alone, I would imagine.
Yeah. And Tim said if you buy from PackSite directly, you can get an e-version while you wait for the hard copy. It's brilliant, absolutely brilliant. It's just sat on my desk open while I'm flicking through things because it just makes such a difference. And Andrew's got the Kindle version.
Yeah.
Right, well, lovely people. I am going to let Melissa go, but thank you everyone for joining us. I will put this onto YouTube this evening, so it'll be ready in the morning, and Melissa will give me the PBIX so that you can work through it. But just on behalf of all of us, Melissa, a huge thank you. That was absolutely brilliant. Really enjoyed it, and you have a gift for making things that are quite difficult seem quite straightforward. So from all of us, thank you very, very much. I really appreciate it. Oh, you're welcome, Andrew. Oh, right, okay, just a quick one. We've got Jay next week. Jay for visual, for DAX and the new visual panel next week. And also I've got Kane Snyder, and I'll send out a message. Kane Snyder, who is an Australian, in August, and he's absolutely brilliant as well. And it's either first thing in the morning or last thing at night. So I'm going to send out just a little straw poll on WhatsApp just to say, would you prefer first thing in the morning or last thing at night? But Kane is absolutely brilliant. So he's worth sort of 9 a.m. or 9 p.m. type thing. But we've got Jay from Microsoft Power BI at Microsoft, who is talking us through DAX and the new editor and the new visual way that we can use DAX. So yeah, look at the events that we're booked up until August, so there's so many things coming up. It's just absolutely brilliant. Anyway, I will leave you all to it, and thank you so much for joining us. Take care and have a great rest of the evening.
Thank you all.
Thank you.
Cheers.
Thank you, Melissa. I'll stop recording now. I usually forget to do that. Stop recording.